And GNC-1LC countdown 1, step 333, provide trajectory file for launch operation.
LC GNC-1, we will like to select trajectory file 3 for today's operation.
Okay, copy trajectory file number 3. Ops 1, step 334, select flight computer trajectory file number 3.
LC Ops 1, trajectory file 3 selected.
LC GNC-1, trajectory file 3 verified in telemetry.
Copy that, GNC-1. We'll go ahead and check step 335 complete. And Ops 1, step 336, verify ground to vehicle comm is nominal.
LC Ops 1, ground to vehicle comm is nominal.
Roger that, Ops 1. And step 337, verify OrbNav settings.
LC Ops 1 in work.
And LCA on countdown 1?
Yeah, go ahead, LCA.
Yeah, we've completed the MS Rapid Restart checklist at this point, and we're all set.
Okay, copy. Joy on that reset?
That's firm.
Okay, roger that.
LC Ops 1, OrbNav settings verified.
Okay, roger that. Ops 1, we can check step 337 complete, and Ops 1, step 338, initialize nav position.
LC prop lead, cold helium bottles,
OrbNav
submerged,
position
confirmed.
sent.
And copy that lead that we have submerged signal. And Ops 1, I copy OrbNav position set. And we can check step 343 and GNC-1. I'll wait for your call on 339.
LC GNC-1, OrbNav telemetry verified.
Okay, roger that. GNC-1, we'll check 339 complete. At this time, I want a report of readiness for gyro compass align. GNC-1.
GNC-1 is go.
Ops 1.
Ops 1 is go.
And Elec 1.
Elec 1 is go.
And we are ready for GC align. Check step 340. Ops 1, step 341, mode OrbNav to GC align.
LC Ops 1, GC align selected. IRIG is 005624.
And I copy Ops 1, check 341. And launch team, we just passed T-minus 40 minutes to our target T0.
And LC prop lead, step 344, start of cold helium bottle charging verified.
And I copy that properly. We'll check step 344 complete. And TLM LC, countdown 1.
And go ahead.
Yeah, TLM step 345. Let's go ahead and configure our DCOM source to open loop telemetry.
Copy and work. And launch vehicle DCOM switch to open loop, IRIG 005940.
Copy all there, TLM, check 345.
And launch vehicle open loop telemetry now being received and nominal.
Roger that, TLM, check 346 complete. And launch team, again, just to recap here, we're currently working no issues. We were able to have a successful recycle of the MS workstation at the launch equipment van, and all agencies are currently reporting green.
LC, GNC1, OrbNav telemetry verified.
And I copy that, GNC1. And I'll go ahead and check step 342 complete. Launch Team LC, countdown 1, passing through T-minus 35 minutes to our target T0. Ops 1, step 347, enable local launch enable button at the failsafe panel and verify local indicator illuminated.
LC Ops 1, launch enabled and illuminated.
And GSO, step 348, enable your local launch enable button at the failsafe panel and verify local indicators illuminated.
GSO, launch enabled and illuminated.
Copy that. We'll check steps 347 and 348. And at this time, I want to verify RCC enable abort buttons are enabled and illuminated. PM?
Enabled and illuminated.
And RSO?
RSO enabled and illuminated.
And FSO?
FSO enabled and illuminated.
And TD?
And TD enabled and illuminated.
Copy all. We'll check step 349 complete.
LC Ops 1, master global launch enabled verified.
LC Elect 1, launch enabled verified.
And I copy all. Ops 1, Elect 1, check 350, check 351. Ops 1, you can stop sending ECU commands at this time.
LC Ops 1, ECU commands halted.
Copy that, Ops 1, check step 352 complete. And launch team, our next significant effort will be to bring up our FTS system and do our final power on and arm command test, and that's coming up at T-minus 30 minutes. Launch team, LC, countdown 1. We're at T-minus 30 minutes to our target T0. Step 353, poll for final FTS power on and Arm Command test. Safety?
Safety is go.
FSO?
FSO's go.
Ops 1.
Ops 1 is go.
Elect 2.
Elect 2 is go.
We are go for final FTS power on and Arm Command test. FSO, step 354, bring up command transmitter with check channel on.
And work. LC FSO, Waltz command site is on, check channel radiating.
Copy that, FSO. And Ops 1, step 355, apply external power to FTSA and FTSB.
LC Ops 1, FTSA, external power on. FTSB, external power on.
FTS, external power is nominal.
LC Elect 2, FTS is safe, configuration verified, check channel being received, and AGCs are nominal.
And I copy all, check 356 and 357. Ops 1, step 358, you go to transfer FTSA and FTSB to internal power.
And work. LC Ops 1, FTSA and B, internal power on, external power off. IRIG is 011045.
FTS, internal power nominal.
Copy all, check 358 and 359 FSO. Send FTS receiver arm command for 2 seconds, then remove. Continue check channel when function removed.
All right, copy. Arm on my mark. 3, 2, 1. Mark. +1, +2. Arm removed. Check channel continued.
LC Elect 2, FTS arm indication received, FTS currently indicates safe.
And FSO verify FTS arm indication.
FSO had arm indication.
LC Elect 2, FTS safe and arm, and FTLU safe.
And I copy all, and that completes steps 361, 362, and 363. And launch team LC countdown 1, we're at T-minus 25 minutes to our target T0. Step 364, report readiness for recalibration of engine pressure sensors, MES2.
LC MES2, ready for engine pressure sensor recal.
EHS1.
EHS1 is go.
And we're ready for engine pressure sensor recal, Ops 1, recalibrate engine pressure sensors.
LC Ops 1, in work. LC Ops 1, engine pressure sensors recalibrated and ready for flight.
Copy that, Ops 1, check 365. Prop 2, LC, countdown 1, step 366, place OCCS into SAC mode and pause HSS ASC.
LC Prop 2, in work.
And LC, prop lead, EHS, RP configured for final countdown.
Copy that, prop lead. We'll check 368 complete. Prop 2, resume HSS ASC.
And HSS ASC resumed, and 370 in work. And OCCS in auto control mode.
Copy all. Prop 2, Ops 1, 371. Enable ME1, ME2, TVC, and EHA buses.
LC Ops 1, TVC and EHA buses enabled.
Copy that, Ops 1. Site control, step 372, ARM-TEL for rapid retract.
LC site
and
control,
welcome
to
everybody who's listening to us on YouTube. This is Peter Coles here at Wallops Island, Virginia. And you're listening to the Countdown Nuts. We're going to keep that up while we're going on here. Here's a live view of the pad from NASA TV. Right now we're about
and tell
20 minutes
LC
away.
countdown 1.
LC TEL, go ahead.
Yeah, step 373.
Rapid retract arming is in work.
Okay, copy that. I'll wait for your call on that. GNC1 LC step 374 provides status of upper level winds.
LC GNC1, upper level winds are go.
Copy, upper level winds are go. We'll check step 374 complete.
That was one of the
Stage
last
1 provides
weather
status
things
of cold helium bottle supply
looking
pressure.
at. Live here in Wallops Island, just outside of the Assateague Island National Park.
LC topping is required for today.
Copy that. Stage 1, your go for step 376. Coordinate helium topping on the ground net per appendix.
Partner
India
in
with
crime
prop
will be
3.
jumping in here and there. Correct?
Copy.
It happens. Every time we try to pay attention to launch control, we end up walking over them now and then. It happens.
Go ahead, LC.
Well, there's so many steps going on
enable.
leading up to the launch that, yeah, you're going to
Arm
step on
enable
them
rotated,
once in a
arm
while.
enable illuminated.
We're getting used to
And you
the
go to arm
delay.
Stage 1 controller ODM.
Yeah, we're
You
getting-
too, huh?
Yeah.
Stage 1
Yeah.
controller.
That's why I have one
ODM
earphone
arm.
off.
Yeah. So this
Ops
is
2,
the
step 379,
NG-14
set
mission.
Stage 1 controller EPVV refs.
LC
We can fade them out
stage 1
for a little
controller,
bit.
EPV ref set.
Copy that. We'll check
We're using a
379
different
and
switcher
system
system
LC, step
this
380.
time. And believe it or not, we're in a McDonald's parking lot
In
on
work.
Wallops Island.
Copy and work.
Only about 10 media members are on the base right now, and we're not one of them. So we found the next best thing.
It's not that bad. We're a few more miles out than what we normally would be, but we have a clear shot down over to Pad OA.
Which is what I'm on right now. We're on that shot. We also have a feed from NASA where we're catching the countdown net. And let's see what we got.
LC TEL on countdown 1.
Yeah, Tal, go ahead.
Rapid retract arm is complete, and you can also mark step 49, which was the equalized pressure is not required.
Copy that. Step 49 is not required, and the rapid retract is armed and complete. We'll check step 373.
So, Pete, this NG-14
LC
mission
Countdown.
Go ahead, System.
is another
Yeah,
Ares
check
230 plus
step
vehicle, and they're carrying a Cygnus
Copy that. We've made our final
spacecraft
adjustment to payload
up to the
ECS 10 step point.
ISS.
Check 380 complete.
Right. Nice thing about
And
this
launch
system
team will
is
be, beginning
carries
with
about
balance
4
top
tons
off
of
here
cargo.
in, just a
They're
little
bringing a
over 3
lot of
minutes.
fresh stuff.
It's actually one of the heaviest cargoes that the Antares 230 Plus has actually launched. It's looking at 8,100 pounds.
Right. When they went to the 230 Plus configuration, they went full maximum thrust for the entire time. They never throttled down the engines per se. They go full thrust from pad to cutoff. So they stiffen the rocket a bit to handle maximum dynamic pressure, max Q, if you will. We hear it called out all the time. They stiffen the rocket up to handle those forces while in liftoff, so they can run full engine throttle all the way.
And speaking of full engine throttle, this is a two-burn launch. Several major steps or milestones in this launch. Once you have ignition at 3.7 seconds after ignition, I'm still getting used to that delay.
Take one headphone off.
Yeah.
That's what I did.
And
it's helpful.
3.7 seconds after ignition, you have liftoff. And then at sometime between then and 3 minutes and 18 seconds, you're actually going to have max Q, which they don't actually put on this chart. But it'll happen between then and 3 minutes and 18 seconds when you have MECO, or main engine cutoff. At 3 minutes and 24 seconds, you will be seeing stage separation. At 3 minutes 54 seconds, fairing separation happens. At 3 minutes and 59 seconds into flight, interstage separation starts. 4 minutes and 7 seconds, stage 2 ignition.
Sounds like you know what you're talking about.
You know, at least the people who printed this out know what they're talking about. At 6
and we've
minutes,
actually been up close and personal with the second stage, a Castor 30 XL stage.
Yes. The stage 2 burnout will happen at 6 minutes and 52 seconds, and payload separation will start at 8 minutes and 52 seconds.
Okay, you done
That is
reading
my
off the
report.
chalkboard? So we've seen the horizontal integration facility on Wallops Island, where they put basically stack the rocket horizontal, and they do the initial load of everything in the horizontal integration facility. God, I sound drunk. I can't even listen to myself anymore. I'll just listen to myself. I don't need to listen to the countdown net. So when they stack the rocket in the horizontal integration facility, oh, there I am. Aha. I turned myself up. Okay, now, much better.
LC, this is prop lead. Actual
So
F1
basically,
and
the next
logo
rocket,
is
NG-14, is already being stacked. The next rocket up is already in the building, ready to
if
go.
we were allowed up onto that Wallace facility, we'd be looking at it.
Right, NG-14 is ready to go. It's on the pad.
Yes.
So what they do is they roll it out horizontally on the transporter erector, which is, you can see vertical on the pad right now. And the next one's ready to go. So what they're doing, and they've starting since NG-12, they tested it. NG-13, they perfected it. The top of the fairing can be removed, and they basically roll this building up to it. It's a mobile clean room.
That's something new as of about 2 missions ago.
Right. So it calls for late loading items, and we're going to watch a video in a couple of minutes, maybe about a minute or two, as to what's on board. Some of the items I saw going up, brie cheese.
Yes, you know, the last-minute load items, they could
They're all
be
perishable
something
items.
live, too.
Yep, perishable items. So I saw different foodstuffs that the
Ice
astronauts have
cream
requested.
has gone up.
Yeah, but that's temperature controlled, so that's
Yeah.
okay. But stuff that's perishable items is what they do in the final load. So they did that this morning, sometime around 3, 4 o'clock this morning, and the rocket probably went vertical around daybreak is what they usually do for stuff like this.
CMDLC, countdown 1.
So what we're seeing now is, countdown nets are proceeding. We're about 14 minutes away. So why don't we take a look at what's on board this mission?
Okay, this is CMD. Yeah, CMD, you go for step 385. Transfer Cygnus to launch mode. Oh, CMD and what? Copy 1.
LC, core 1 on countdown 1. Fuel level adjustment is not required.
Copy that. Fuel level does not require adjustment.
Developing cancer cell-specific biological drugs that can selectively and effectively go after cancer cells. And we uncovered that cancer cells have a foreign language that they only speak in the body. This allows us to exploit this language to encrypt our biological drugs in that foreign language so only cancer cells can understand us. So we're doing this extreme form of stress testing under microgravity. That is our first achievement. If we can identify at least one candidate that is resistant to leakiness in normal cells, despite being pushed to this microgravity conditions, then there's a good chance that when we go into the clinic with hundreds of different types of cancer cell ribosomes, cancer cell biomarkers, then we will be able to still rely on this asset for clinical development.
Astronauts will take our cells and put them back into the proper 37-degree cell culture incubator. And then with syringes, they are going to apply our reagents into the cancer cells and the healthy cells. And then the next day, they are going to do the readout and see whether this differential behavior is recapitulated in microgravity conditions.
This is all about betting on the right assets for future development, because drug development is costly and it takes time, and we're also building hope with patients. We want to identify the best candidates for them.
I know it's a toilet, and I get a big laugh from my friends all the time, like, oh, he's building a toilet, and you're like, not just a toilet, a titanium space toilet. So it's pretty nifty, especially when you get into the complexities of it.
The UWMS is 65% smaller and 40% lighter than the current toilet used on ISS. Our toilet will be installed just adjacent to that toilet and will undergo a concurrent use with that toilet as we do the demonstration.
One of the things the UWMS has to do is it actually has to inject pre-treat into the urine before it sends it to the urine processor assembly. The pre-treat is a very strong acid, and it is not very compatible with a lot of materials, so that forced us to have to use a lot of exotic materials such as Inconel, Elgiloy, titanium. So one of the coolest things that we actually did on this project is we implemented a process called Electron beam powder bed fusion. That's just a big fancy word for 3D printing. When we go to the bathroom here, gravity pulls everything to the ground, essentially away from the body. Well, in microgravity, when you go into space, you don't have that luxury. So we have to essentially create our own artificial gravity. So at the heart of the UWMS is the dual fan separator, and that's actually the part that's actually made out of the 3D printed titanium.
Exploration is a hard business. It's uncomfortable. There's a lot of things that the crew has to do just to explore. And the goal with the UWMS is to meet the challenges of spaceflight in terms of mass and volume and power usage and keep within those constraints, but also make it a system that the crew has a more likelihood to be comfortable with.
The objective of the experiment seems very simple, and it is growing radishes on the ISS. I know that radishes have been grown several times, but never in the advanced plant habitat, where we have actually enough space to grow a number of plants that allow us to do some statistics.
Plant habitat is currently the largest, most complex plant growth system on the space station. The actual growth volume itself for plants measures about 20 by 20 by 20 inches cubed. So all the rest of the volume of plant habitat is all of the stuff that it takes to provide a controlled environment for the plants that are growing inside of the growth chamber.
Radishes grow to a sizable volume, and a big piece of that mass is the radish itself, that bulbous tissue, and the process of developing this secondary tissue is completely unresearched in space. But it is relevant because it is sensitive to all these things that we have on station. So it adds to this rather complex set of data that we need to get a handle on to properly grow and understand the cultivation of plants in space.
To go to Mars is a long haul, and to go any further than Mars is longer yet. So without a doubt, unless we are going to have space vehicles that have rotating elements that can provide some fractional gravity, there's going to be a microgravity area. And in order to grow a reasonable amount of plants, we're talking about much larger systems.
And so this experiment is one way of trying to get a little closer.
For the past 2 years, we have been in intensive production on a project called Space Explorers, the ISS Experience, that is filming inside and outside of the International Space Station through the immersive power of virtual reality. And in a few months, we're going to take the camera outside to document a full spacewalk and to film exterior shots of the space station as well as shots of planet Earth. What we are doing now is getting ready to launch our EVA
right now, but I want to get goes or go pending on our poll to proceed with final countdown. Our planned pickup time is at 013244, and that's in just over 2 minutes. GSO?
To make it basically resistance to
RSO.
pressure of
RSO
space.
TD?
TD
is go.
Variations in temperature, so we had to make sure that the lenses were also certified for use outside.
MES1.
And we're basically going
MES1
to use Dexter and the Canadarm as
Ace
kind of a celestial crane.
And Mars?
As you would in the movie.
And everybody else can stand by.
So it sounds like we're working an issue on the countdown net. By the way, we're live here.
Launch team, we're going to be picking up the count in just over a minute here. Again, our new target T0 time will occur at 014344 UTC. That's 014344 UTC. Ops 2 LC.
Looks like we do have a window because
there is a window.
We're going to delay start of engine evac until I give you direction to do so.
Copy that.
Working an issue on the countdown net. New 0143 UTC, which is 9:43.
LC stage 1 is go.
Okay, copy. I've got stage 1 go.
And thank you for joining us this evening for the launch of the Antares rocket from Wallops. New launch time is 9:43 p.m. Just a reminder, if you're watching on the Ustream, that you'll probably have a 20-30 second delay from actual activities here at Wallops. So if you're looking to go outside and try to catch the launch from where you're at, just take that into account.
That'd be Keith Kohler of NASA, giving that update on the Ustream.
Okay, I want to complete our poll to proceed with final countdown. Prop lead, countdown 1.
Prop lead is go pending 1914 reading dry.
Copy that. Prop lead, GC. Copy that. CMD.
CMD is go.
LD.
LD is go.
NG.
In honor of Kalpana Chawla, who inspired millions of people as the first woman of Indian descent to fly into space, Northrop Grumman is go.
Copy that. We are going to proceed with final countdown. Ops 2, your go for step 389. Start engine evac.
LC Ops 2, engine evacuation started.
Check step 389.
And we made it through the polls.
So apparently they were working some issue while we were seeing the What's on Board video, and that issue seems to have cleared because they've given a green light.
So did I hear correctly during that video, they are sending a toilet up in the Cygnus spacecraft?
Yeah. It's a new model of toilet. It's going to be installed right next to the old one. So now there will be no waiting on the ISS to use the facilities. It's actually a whole new design. It's much lighter than the old one.
What was waiting an issue on the ISS?
I hope not, but you never know. We'll never hear about it.
No.
We'll never hear about it. But just to let everybody know, we are here in the McDonald's parking lot here in Wallops Island. Believe it or not.
Ops 1 LC, countdown 1.
Sorry, Shingiggly Island.
Go ahead, LC.
Yeah, step 391, enable ACS VDMs.
It's such a force of habit to say Wallops Island.
I know. I'm used to being.
VDM's internal power on.
I'm used to being in a different location for this.
ACS VDMs enabled, voltage nominal, ODM command
this much gear.
Copy that. Elect 1, check 392. Launch team, be advised. Step 393 is not required for today's operation.
That's good. We're skipping a step.
Site control, wait for your call on 394.
Mm-hmm.
LC MES1, step 390, vacuum verified.
Copy that. MES1, check step 390 complete.
So we're about 8 minutes away from launch.
So during the Northrop Grumman or NG check during the polls, every time they send a vehicle up, it's named after somebody who's done something for space. And this time around, it was Kalpana Chawla, and she is in space in prominent history
control,
as the first woman of Indian descent to
Copy
go
that.
to
Site
space.
control, check step 394 complete.
And unlike others,
and
we leave the countdown
wait
nets
for your
up.
call on step 395.
We talk over them.
Now that we know that the polls went okay, I don't feel that guilty. When we get down the terminal, we need to shut up.
So we're reading about 8 minutes to go. We added 5 minutes onto the window. So we'll be going at 43 past the hour.
And when that does launch, that first stage, we'll be burning liquid oxygen and kerosene.
Rocket grade kerosene.
Rocket grade kerosene.
Not the stuff you burn in your home.
Not the stuff you put in your lamp?
No.
After that, when it does go into stage 2, that is a Castor solid motor rocket engine.
Right. Northrop Grumman used to be Orbital ATK. ATK produced the shuttle rocket, solid rocket boosters for the shuttle. So they're very good with solid rocket engines. Same engines on the Minotaur. So they're very good at a solid rocket booster. It is unusual for a second stage to be a solid engine. Because once you light it, it goes.
Now a solid engine, there's no throttling. You light it, and it just
LC,
goes
this
until
is
it burns
3
out.
on countdown 1.
Go.
I can confirm step 395 VTSO activation verified.
Copy that. Check 395. Ops 2, step 396. Initialize ground ordnance power supplies.
LC Ops 2, ground ordnance power supplies initialized. Ground ordnance power supplies nominal.
Copy all. Check 396 and 397.
Once the Antares vehicle is launched, it will take 2 days to make its way to the ISS, where it will be berthed for 90 days.
Transfer to GN2 confirmed.
Roger that. Site control.
Right,
Check
what
step 398
Northrop
complete.
Grumman has been doing on these missions before at Orbital and then Orbital ATK is they have other missions on board on the kick stage that are small sats, CubeSats, things like that. They go to the ISS. Once the mission is done with NASA, the Cygnus spacecraft detaches, goes to a different orbit, usually higher, and deploys all their small sats and CubeSats. So they have to wait.
Also, what happens with the Cygnus spacecraft is they're putting their trash on that too.
Correct.
So at some point, once the Cygnus is done with all of it,
All their
elements
mission.
of its mission,
Mhm.
it does a controlled burn through the atmosphere, and that's how the ISS gets rid of their
And Ops
refuse.
2,
Yeah, look at
LC,
that. Nice
countdown
shot of the
1,
moon by
step
NASA.
399. Here go to initiate engine priming.
One of the remote cameras, they were shooting the moon.
LC Ops 2.
It is a nice full
engine
moon
priming
here out here
started.
on
Ops 1, you go to
Chincoteague
transfer
Island
avionics
tonight.
to
We
internal
actually
power.
couldn't have asked for a better
LC
reason.
Ops 1, avionics internal power on.
Let's take a look at your camera shot.
Standby 5.
Actually, from your shot, we can see the Vapor trail coming off the rocket. Are you going to activate your monitor?
LC 1, all external power off.
External power has been disconnected.
Internal power is nominal. Copy. Elect 1, Ops 1, step 402. You go to open FTS UMBI loop.
LC 1, FTS UMBI loop is open.
LC Elect 2, FTLU and FTS receiver indications are nominal.
Copy. Elect 2, Ops 1, you go to send all arm command.
LC 1, all armed command sent.
Approximately 3 minutes from
all
launch.
armed. Master TD, step 406, report range status.
LCTD, range is green.
Copy, range green.
That's a good call right there. Range is green. Nobody in the violation area. And all equipment on the range is working. Reading
LC priming
under
verified.
3 minutes to launch.
Copy, we have priming verified. Check step 407 complete.
Welcoming everybody into Chincoteague Island. You're taking a look at Wallops Island from the NASA feed. Here's our live feed from our vantage point a couple miles away. We are in terminal count now.
Launch team, be advised, phase 3 dynamic limits will be active at T-minus 3 minutes.
FC commanded to flight mode.
Copy. Elect
Countdown
1.
net is a little bit behind.
Auto sequence start. ODM voltages and currents nominal.
GNC1, verify, ready for nav mode.
LC GNC1, ready for nav mode.
Ops 2, 414, switch to nav.
Orb nav, switch to navigate.
And LC, this is prop lead. We are
LC
OTCS
GNC1,
automated abort.
orb nav, telemetry verified.
This is launch team on countdown 1, abort, abort. This is LC on countdown 1, abort, abort. We will be proceeding with abort safing 8-9. That's abort safing 8-9.
So the board has been called tonight. They're calling it a board on the countdown net. And other people are reacting to that as well. I can hear people over on the bridge.
We already hear engines starting back up. And I'm not talking about the NG-14.
Correct. So we have an abort on the pad. It sounded like it was prop loading.
Okay, TLM, you're go to disable on Alpha 3, disable using no embedded data stream.
And data stream is suspended.
And Core 1 direct, use NOIA to restart their MS session. Report when complete.
In work.
Copy and work.
So it sounds like we got to the end of the
proceeding,
window.
Let's press with abort safing 7, step Alpha 6, Ops 1, disable your local launch enable button. Verify indicator extinguished.
LC Ops 1, launch enable removed.
And GSO step Alpha 7, disable your local launch enable button at failsafe panel and verify local indicator extinguished.
So we do have a launch aboard here.
GSO launch enable removed.
Copy that. Ops 1, step Alpha 8, verify removal of master global launch enable.
Removal of master global launch enable verified.
Copy that. Ops 1 and Alpha 9, deactivate your arm enable at the failsafe panel.
Arm enable key rotated and arm enable no longer illuminated.
You know, we could talk about this. Let's fade out the
Roger
countdown
that.
nets.
And MES2.
It's been a tough week for rocket launches.
Not just here.
Delta IV Heavies tried twice and failed to launch. SpaceX had an abort this morning with like 7 seconds to go. It's been a tough day.
Yes.
It's been a tough day all the way around for launches. With SpaceX abort, Delta IV Heavy again with a under a minute launch abort.
Right.
And with us under 2 minute launch abort.
Yeah, it was under 2 minutes. Like
it's not the first time this has happened.
Yeah, the first launch I was at, there was a safety violation. It was a boat or an airplane.
Right.
Yeah, and that was under 2 minutes.
Mm-hmm.
But this is why we plan ahead and we book a few extra days.
As they say, rockets are hard.
Priming initiated. Can you
Nope.
verify if that's complete?
Nope, they're safe in the rocket right now. No, they usually could do a 24-hour turnaround. Yep. Unless it was something major. In which case, I won't be here anymore.
Yeah, they will probably be announcing a date and time later on.
So we have a launch aboard tonight here at Chincoteague Island and Wallops Island. We're waiting on whether we hear another launch scheduled date. They'll probably have to verify with the range. Now, problem with that is, right now, SpaceX has a scheduled launch tomorrow night. So we don't know what the range is going to say to that request. They may give priority to this mission because it was already in the books and it is carrying items to the ISS, and their schedule dictates that they need it in a timely fashion. So we'll see, and if so, we will reschedule tomorrow and go on the main channel, as there will be nothing conflicting with us on Channel 15. City Council meeting will not be going on tomorrow. So look on the Facebook page for updates, and we'll conclude the broadcast in a minute or two. But thank you for tuning in tonight, and hopefully we'll see you again on the next launch attempt, which should be tomorrow night. If not, we'll probably have to cover this one by remote. Thanks everybody for tuning in. We'll be terminating the broadcast in a few minutes. We'll give you a live shot of the pad, and we'll listen to some of the countdown nets.
Likewise.
And this is the Wallops Flight Facility. We have scrubbed tonight's launch of the Antares rocket. Next possible attempt would be tomorrow night at 9:16 p.m. However, we will, the crew will need to look at the issue that came up tonight and make that determination. So I would suggest watching the NASA social media feeds, and also the Wallops main page website, and for the latest information on the next launch attempt for this Antares. Thank you for joining us tonight, and have a good evening.